Now, sometimes we don't need to meet both of a pair of conditions. Sometimes we only need to meet one of them. Suppose some piece of machinery is only safe to operate if one is under 1.7 meters tall or over 1.9 meters tall. I don't know, it has some sort of spinning blade that's perfectly placed to decapitate someone 1.8 meters tall. How would we describe this rule, though? If h is the person's height, we would describe this rule as h is less than 1.7 or h is greater than 1.9. Now I want to call your attention to this word or, because the word or in mathematics has a slightly different meaning than it does sometimes in English. In math, or always means one or the other or both. The or both option is always included in mathematics. In everyday English, it often isn't, right? At a restaurant, they'll say, your meal will come with soup or a salad. If you try to get both, you have to pay extra. If you're walking through the forest in the 10th century and I leap out and point a bow at you and say your money or your life, and you give me all your money and I still shoot you, you're going to be really mad. Right? That in common English usage is called an exclusive or. Mathematical or is always an inclusive or. It's not your money or your life. An example of an inclusive or in English might be something like, this Saturday I'm going to clean my house or see a movie. If I both go to the movies and clean my house, you wouldn't say that what I told you wasn't true. Or is a little bit different than and because it's a little bit tricky to think about. But the procedure for solving or inequalities is exactly the same. And as an example of this procedure, let's see, say, 5x minus 4 is less than 8, or negative 2x plus 3 is greater than 7. Right, so just like with the and inequalities, our first step will be, first we solve each inequality separately. And then what do? Do you imagine? We connect them with the word or. And then finally, just like with the and inequalities, we simplify if it's possible. And we do pretty much the same thing. We draw three number lines. X is less than 2.4. X is less than negative 2. But now we don't look for where they overlap. We look for the points that are on at least one of the rays we marked, right? So these points in between here are on this top ray, so they're in, with a round bracket over here. This point right at negative 2 is on the top ray. These points over here, well, they happen to be on both rays, so they're also in. Remember, one or the other or both. So it looks like this picture is exactly the same as this picture. Right? It's enough to just say x is less than 2.4. Right? Allowing x's that are less than negative 2 doesn't qualify any new numbers that weren't already qualified by being less than 2.4. If we write this in interval notation, we'll want negative infinity up to 2.4. We notice 2.4 has a round bracket. Let's see another example. Let's suppose we have the compound inequality 2x plus 5 is greater than 7, or negative 2x minus 5 is greater than 7. Well, first we're going to solve each inequality separately. Subtract 5 on both sides. Divide both sides by 2. I get x is greater than 1. How about over here? Add 5 on both sides. Divide both sides by negative 2, and what has to happen? Right, I reverse the inequality. So now I'll connect these to the word with the word or, and then I'll look at my 3 number lines and see if I can simplify. Right, so negative 6 is somewhere over here, 1 is somewhere over here. X is greater than 1, x is less than negative 6. Here are the x's that are greater than 1. Here are the x's that are less than negative 6. Now down here we want to mark all of the values that are on one or the other or both of these lines. Well, points over here are on this line. Points over here are on this line. So it looks like I don't have any extra information here, right? I need to say x is greater than 1 or x is less than negative 6. If I want to write this in interval notation, notice I have a gap here. So I need to write the left half, and then for the gap I write the union symbol, and then the right half. So this interval notation expresses the solution set to this inequality. Just like for and, there are 4 possibilities with or inequalities. But one note on or inequalities, we can never, ever, ever write an inequality involving an or with this betweenness notation, because this betweenness notation means and. It's part of the meaning of this notation. So this notation, not for or.